Hi, it's Joe here, ZL1PMY. So like everybody else, we're in lockdown, so I started digging things out of the storeroom to refurbish that I've been meaning to refurbish for some time. The lack of practice talking to people is affecting my ability to produce words, it seems. So this is the part of the Clansman military radio equipment. It's a tuner unit, 250 watts. It's called the R250, and basically you can use a wire dipole with it or an end fed including a rod, and you've got sort of band select. It's not really band select, but within the matching network you've got L, C and tunable L, and we'll have a look at those when I open it up. Also here, I'm not sure if you can actually see that. I must get a better camera than this, but this is not illuminated when it's working, but here you'll find the lengths for various things: frequencies, the tune position, the match position, and the C select, the fixed C select. So basically it's a matter of putting some sort of LED inside there. I'm probably fitting a push button here. This is the desiccator, but you could take that out and put a push button in there to a PP3 battery and make this thing light up so you can see. It's quite heavy. I'll have to weigh it to tell you how heavy it is. I'll look in the manual. Carrying handle is here. It's secured by Allen nuts all around the outside case, and then if I turn it around, I've just taken out these peculiar shaped nuts. You can see it's a screw with a big washer that comes into contact with the outer case, and these are thermal bolts. These carry the heat from the inside of the tuner and dump it into the outer case. And around the back we've got the rod or long wire output on this ceramic plate and an earthing point. And again, I've taken out the heat transfer bolts. So I'll get the Allen keys out and I'll pull it all apart and we'll see what the status of that is inside. So we've got the unit out of its outer case. This is the outer case. You can see the ceramic plate at the back, which has three prongs actually, two guide prongs and a connecting prong. Maybe you'll see it better there. The case itself is 18mm thick. Why it's not 20mm thick, I don't know. That would have been more standard. And as you see, it's quite capable of sinking quite a lot of heat. But that's all there is to the case. It's just a lump of aluminium with a ceramic plate and a little screw here for connecting your long wire or rod aerial. And then on the front of the tuner, I'll show you the detail of that when we get to it, are the other connections. So stay tuned, as they say. Okay, a quick look at the front panel controls. So it's made by MEL, which is Marconi Electronic Devices, very active in military equipment during the 50s, 60s and probably 70s. The thing here, this rotating scale, you can look up whatever type of aerial you're using. You can look up, don't know if I can operate it with one hand or not, but at the moment that's on an end fed with the counterpoise, and you see it got frequency, length of antenna and the tune match and select positions as a starting point. And if we rotate that round, here we've got a dipole with meters in each arm, and again sorry, it'll be feet in each arm. Oh, it does say meters. Strange thing, this metric conversion, you know, some things are still in feet and others are not. But a dipole at 4 megahertz reports to be 16.5 meters in each leg. And then we go around again, that's blank, and we're back to a 4 by 1 meter rods. That's the copper rods that you can screw together. So that's 4 1-metre rods, i.e. a 4-metre width, and then we've got is it three rods, 3 by 1 metre. Sorry, I'm looking through the camera so it's hard to see. And then back to the end fed. So the switch here selects whether you're on rod or end fed or dipole. This is the fixed capacitor. It's part of the tuning network, and the excuse me, it's not the virus. We've got A, B, C and D, which refers to the points on here. We've got a match capacitor, which has a little scale here. I don't know if you can see it, but that's on 1, and that'll go up to 2, and then it's a combination of this number and whatever you dial in the scale up here. Again, that refers to the match position, match. And then you've got the roller coaster, which has 2 scales, but they're that worn that you can't read them. It's one of the things I've been meaning to do, strip the cabinet off. The meter has nothing to do with SWI, it's to do with the system, i.e. system voltages, and I'll go into that in a minute. This is the RF input from the TX, and the TX is one of 2 types, either 25 watts or 250 watts. You've got a lock and operate. This stops you adjusting the things by accident when it's been set up. You've got the output antenna, so that's C-type. It looks like a BNC, but it's a C-type. And then you've got the harness connection, which is just marked control, and that goes off to the control system for the whole shebang. It controls audio routing and RF switching and all that sort of thing. And there are boards inside this unit which you don't need as a tuner, and they can be stripped out, and that's one of the things I've been meaning to do. So there you go, that's the front panel. I'll get back to you in a minute when I have to turn it around with 2 hands. I don't want to drop it on my foot, so I'll be back shortly. So starting with the inside rear, so this is the receptacle for the pin that sticks out of the ceramic plate on the back, and this plate here is an RF sensor. Basically, if you get a high voltage induced on that plate, it means your SWR is wrong, and that goes into a little amplifier here, which then goes off to the control unit. The inductors, you've got fixed inductors here wound on these ceramic tubes. This one's cracked, but the winding only starts here, so I'm guessing that that's going to be okay. The roller coaster, down here you can see it's silver plated tape. It's not a wire, it's a tape, and that's wound on and off to, I don't know if I can get a glimpse of this, but down there is a metallic drum. So the windings that are not on the ceramic roller coaster are actually shorted out on a ceramic drum. And then the match capacitor, if I can get my hands around the front, I don't know if you can see that moving. That's a ceramic one, and that's geared in a ratio with a smaller capacitor that's under that cover. And I'm not sure why it's under that cover, but it is. And there's some sort of ferrite device down here. Again, I'm not sure what that is. It's part of the roller coaster, I think. And all these wires here and circuit boards which you'll find inside are nothing to do with the operation of the unit as a standalone unit. It's to do with it as a system. Down here is the waveband switch, and that's extremely well made but difficult to get a photograph of. So you can see the very large studs, and maybe if I put my finger in there, you can see how big those studs are. And that rotates with the band. If I can find the right knob on the front. See, there's the one at the back, which is switching between dipole and RF, and then you've got the band switch, which I can't find the right knob for at the moment, but that's the main center one. So let me move it round. Well, that is the main band one. You can see the different bands, different bits move. It's sort of not a geared assembly, but it's pre-programmed for different frequency bands. And then on the side around here you've got a filter section, which I think is what the smaller capacitor tunes, just to give you a low pass effect out of the tuner. And down here you can see the doorknob type capacitors. Now, I don't think anybody's ever found the schematic diagram for these. It's one of those things that was released by the ministry, and although you'll find documentation on what it is and how it's used, the EMA, electrical something regulations, I forgot what EMA stands for, electrical and mechanical regulations, which really means the service manual, and in fact these days it's called something else. It's not an EMA anymore, but that's what they used to be called, would have the circuit information. So in order to modify it and strip it down to its bare essentials, we're going to have to work out exactly what the matching is, and then anything that's not needed we're going to strip it out. So that's my task for my lockup, day 2. We are here, although we've been locked up for probably 4 days now. We decided to preempt it, having done some nuclear and biological training. I decided that we would preempt the jump up in status level and just isolate ourselves. So there you go. I'll let you know how I get on and what it's like, and maybe get to produce a diagram of some sort. Stay tuned, as they say. Okay, so we started the stripping process. The large ceramic or ferrite thing I showed you opposite the one end of the roller coaster is in fact a fan, which is strange really, because this is an airtight box, so all that fan can do is circulate the air within the box itself. There's a whole pile of electronics here which obviously connects to the control unit. I dare say one of those relays turns the fan on and off based on a temperature sensor. Here you can see the metal drum that collects the tape from the roller coaster, and of course all these turns are shorted out, they don't exist. And this gadget here is what drives the numbers in the rotation count, and the way that works is each of these little discs overlaps the next, so one complete turn would take that disc all the way around, and then it would line up with that one, and then another complete turn it would line up with that one, etc, etc, all the way along there. So you get 0 to 90 turns on the turns counting gauge, and that's the way that works. So yeah, I'm going to chop this out. We don't need that. I think the board here, you can just see there, it's probably a TO5 transistor on the other side of the board. That's probably the actual switch that drives the fan. Maybe the fan is variable speed, not sure. But as I said, no one as I know has ever found the correct EMA for these. There's a strange story to that. When all this kit was manufactured, the documentation was issued to the army on a loan basis, on the condition it had to be returned to the OEM or the original equipment manufacturer when this stuff was ceased with. Well, it was in service that long, it went well over its normal replacement date, that a lot of the original equipment manufacturers had gone out of business, and so there were containers and containers full of documentation that nobody knew what to do with. So sadly I think a lot of it was destroyed. There's an organisation in the UK called the Vintage and Military Amateur Radio Society, or VMARS. I think you'll find them on vmars.org, who were given a lot of that documentation as the custodians, and if you're a member you can request various documents. I used to be a member in the UK, but not since I've been out here. So there you go, a little bit of progress, and we'll carry on digging and try and fathom out exactly how it all works, and I'll get back to you soon. So having taken a jam jar full of screws out of the thing, we stripped it. I'll show you the chassis next. These are the bits that have come out that are surplus to requirements, but I might use some of them again. You may remember that strip on the ceramic backplate that picked up RF voltages and it connected via a coax cable. Well, this is obviously a detector unit, and you can see it says RF volts trip. So obviously if you got the SWR really wrong, and there was a lot of volts, RF volts in the thing, it would stop the transmitter from pushing power in. And that's what the rest of this control unit does. That's surplus, as we don't have a system to connect it to. All that is surplus. A lot of these this range of radio equipment was meant to connect via finger and fork connectors. They call them finger and fork, and as you see, they've all been soldered up, because what they found in service was that they were very prone to bad connections, and so the technician, one of the mods, would be to run through all of those and solder them up, which meant they weren't that easily stripped. This is the input voltage filters from the control harness, so we may reuse that to put 18 volts in. And this was the regulator inside. It's a 2N3055, and again we may rewire that and use it to control the fan. So I'll get the chassis up next and we'll take a look at that. So here we've got the actual RF chassis. This coax is the RF output for the dipole, and you can see here now properly the beautiful heavy duty ceramic switch. That whole turret rotates. I don't know if you can see, but they're sort of little bridge type connectors that rotate, that join these spring loaded, these are spring loaded connectors together. There are a number of door knob caps and the roller coaster on that side, and here you can see properly the fan, which appears to have a ceramic housing, and all the drives are these slots, and the other side is what should we call it? Well, these are male, and the other side are female, I suppose. So that's a whole sub-assembly which would have been married up to the front panel, and I'll get that up next. So here we've got the back of the front panel. You can see the other half of those drives. These are magnetic, field magnetic. They're certainly captive anyway, so to make it easier to assemble the thing. And you've got the fine capacitors still on top. All this is sub-assembly. The filter is still on the side, and we've whipped all the knobs off. So what we're going to do with it, we're changing the harness connector to put some sort of commercial power connector on there, which would have probably 4 pins, and that would go then into the filter unit, which we're keeping. We're going to put LEDs in here, working from a push button, and LEDs behind these two on the main number. This one doesn't have LEDs, it's actually printed on the knob, and sadly the knob is, as you can see, it's a bit it's been fitted so close that it's been rubbing, and you know, you can't read the numbers where they rubbed off. We're going to change the output connector, probably to an N-type, although we might just match the BNC on the input to the output, depends what size of hole we've got there. This thing is a timer, it's not a desiccator, it's actually a thermal timer, and we'll take that out, and that would make a great place to have a push button to illuminate it when we needed it. Alternatively, the lock and tune mechanism, if I can flip it back over, the lock and tune mechanism has a little micro switch which when it's in lock position, the micro switch is operated, and again that could be used to actually illuminate it. So while it's in tune it would be illuminated, and when it's in lock you would turn the LEDs off. It's full of little switches which obviously change. You can see here that this rotary mechanism has 3 contacts, and that's some sort of switch, and they appear to change the gain of the detectors for different frequencies. As you might imagine, the RF volts out of an RF detector would change with frequency, and I think what they were doing was making it a level playing field, so that as you went up or down in frequency the gain of that detector was changed. Only a guess, so there's no manual for this. This little RF circuit here is on the input side, and again I think that's something that we would investigate, see whether we can keep it. Certainly the meter, we're likely to put a reverse SWR detector, a reflection, so that you just tune for minimum rather than maximum, if that's at all possible. The 2 capacitors here appear to be in some sort of logarithmic arrangement, I would think. So as this one is increasing, this one is decreasing, and again the switches here determine which of the 2 halves of that capacitor come into service. So you get for a fairly large number of turns, you get quite a large range of capacitance. And as I say, the filter, the RF filter on the side is still present. So quite a bit of mechanical work to do to it, and then a bit of wiring, and we'll get on with that, and I'll add to this video a little bit later on. Okay, a quick update. We're just in the process of putting the thing back together. As you may be able to see, we put some illumination here, and in the guide. This is not an active component, it's merely a script of where you start from. We've also used the tune and lock switch, which is down here, to deselect those lights and put the internal fan on. So it sounds noisy now, but once it's in its case, which as I mentioned earlier is an air-tight case, so the fan can only push the air around inside, you know, it shouldn't be that noisy. So what I want to do next is to tidy the bench off, get the analyzer out, the VNA, and just sweep that front end to see what type of coupling it is and what it's got and what its frequency response is, and then rejoin that to the switch capacitor and roller coaster and test it out with some fixed resistors to see what it matches to. So yeah, there you go. I'll be back very shortly, maybe a day or two, as we're home alone with Mrs. B, and there are some jobs waiting. Okay, now we've got the unit back together. As you can see, the illumination is working, and although you can hear the fan in the case, it's not that loud. Let me turn it on, and probably I'll add another switch to not use that at all, turn it off for the noise. But before we delve into the circuit, we'll just go through the front panel controls again. So you've got a selector here between a dipole and a rod or an end-fed wire, so you can select either or. You've got a select switch for which is just marked A to G, and again I'll go through that. When we look at the circuit diagram, I managed to work it out. We have a thing called match, which is a capacitor. It's actually two ganged capacitors, and they have a ceramic switch on the back of them, so that as you rotate it at different points of the rotation, there's either one or both capacitors in circuit. And then we have the variable inductor, which is that silver tape wound on a spool, and you can see there the numbers changing. The tape that's not in use is wound onto a metallic drum, which stops it working as an inductance. It's just a short circuit. And we've added a fuse and a PL259. The RF is still going in on a BNC, and we've got this lock and tune, which turns the lights off, puts the fan on. So I'll get the drawing of the internals, the schematic, and I'll just run through what we found, just out of interest really. It is a lockdown period after all. So while we had various connections disconnected, I managed to put some test gear on the various elements, and what we found out is this tuner is capable of being both an L match and a pi match. Now when we talk about an L match, there are actually 8 configurations of L, which just simply refers to the shape, the configuration. But you can have, as you see here, it's series inductors, parallel capacitance, series capacitance, parallel inductance, and then simply moving the capacitance and the inductance to one side. So you get both low pass frequency configuration and high pass frequency configuration, with either a downward impedance conversion, i.e. a high impedance to a lower one, or vice versa, a lower impedance to a higher one. And that's the nature of an L match. Whereas a pi match is usually 2 capacitors, one or both tunable, and a series inductor. So if I flip the page, we can actually take a look at what's in this unit. I can find it. Here we go. So within the unit, we've got the RF input here going through a low pass filter, and then that goes into the variable inductor, and tapped off that are the tunable rotary capacitors, the adjustable capacitors, and they are arranged so C1 is actually the ceramic one, and that's 7 pf to 350 pf, and then these two are ganged but set slightly apart in terms of rotation, and they give us something like 80 pf to 5 nanofarad, quite a large range, and that's actually made of the pair, a pair of 40 puff to 2.5 nanofarad. In the L configuration, you would simply have parallel capacitance, series inductance, and the band switching, the frequency range switching, would actually short out this capacitor, and that would give us an output to the long wire only. That's in position A. When we switch to any other position, it becomes a pi coupler or pi tuner. So we have parallel capacitance, which is variable, tunable, series inductance, another series capacitance across which is switched additional values from this switch here, and the values are arranged so that they increase. The switch is wired such that they increase or decrease by adding them together, and typically we've got 30 pf, 200 pf, 470 pf, 1 nanofarad and 150 pf, which would be on the output side of the pi coupler. Now in an earlier video I said that the inductor was a roller coaster. That's not quite right. A roller coaster is an inductor which has a tap which runs up and down mechanically along the spool of wire. A variable inductor is an inductor which you can wind off the turns from the ceramic former and put them on a metallic drum to short them out. So all the turns that are not used in the inductor are shorted out and just look like a wire, and then the number of turns left on the ceramic former form the value of the inductance. So that's basically how it goes on. These capacitors have their own switch on the back, and roughly speaking, if I can read it through the camera, from 10 degrees to about 20 degrees C1 is in circuit, and then beyond 20 degrees, oh no, it's 120 degrees, that comes out of circuit and these two move in, and then the final end of the tuning range, all three capacitors are in circuit. So that's it in a nutshell. I know it's not a construction project, or it's not a lecture as such, it's just a glimpse of what's inside this ex-military tuner, which were once quite sought after in the UK. When Clansman, it comes from a radio range called Clansman, and when they were first being disposed of there was quite a demand, and then suddenly the Polish started to buy them by the containerful, and they were taken back to Poland and simply stripped for their valuable metals. There's a lot of silver and gold content in Clansman radio equipment, and the rest went to scrap. So quite a shame really, but there you go. Okay, well, I hope you all keep safe and isolated, and eventually when the restrictions are lifted, which will probably be 2021, we'll see you on the other side. Well, bye for now.